Let's get started. All right, make sure you're at home doing appropriate stuff, people. If not, get Disney Plus because it's probably better than Netflix.
Yeah, were you recording that whole time?
No, thank you. All right, so geothermal energy, number 43 in the notes. We're on page 362 in your book. We're going to work on and go over geothermal, and then we're going to spend the rest of our time working on some of the math problems. Did I tell y'all to do math problems?
You gave us the sheet.
I gave you the sheet, but I didn't tell y'all to do anything. Good. It's okay, I'll give you the sheet today. We're going to work on, for you people at home, there's a sheet, and I asked you to do the first three of each three sections. There's three different sections. And so we're not going to take too long on notes because it's a pretty short section, and then we're going to work on some math because, like I said, there is a lot of math in this unit. Friday, you guys had an FRQ to do and work on, so hopefully you worked through that, and then you were supposed to go back and grade it, self-grade, and then post that. So I'm not a total idiot. I realize you could have just cheated. It is not for a grade accuracy because I don't trust y'all that much. But hopefully you guys figured out how to do the problem. Did anybody have questions on how to do those problems, the math part? That means they did it and they understood it, or they just didn't do it. So if you do and you weren't sure, you can let me know. But definitely that's going to be something I check for a daily grade.
I have a thing. So
Yes.
when we went over the last three? Yeah, the last three.
The calculations, yes, ma'am.
Yeah, in class. I feel like we went through it too fast. And I got the right answers, but I was just confused to the explanation.
The setup? Well, if you go back to, I don't know if we'll have time. Get it out today, Andrea, and you can ask me if we have time at the end of class. And if not, the rubric for them it's on day 4 that shows you how to work them out. Now, one of the confusing things on the rubrics is they always put them in scientific notation, just about the really big numbers. And so you do not have to put it in scientific notation. You can just write out the answers, and which is what I usually do. So either way is fine. But if you're having trouble with the setup, like I said, we'll look at the setup on the rubric, and if it's still confusing, then we can definitely go back through them and make sure you understand how to do that. Today should be some more really good practice for, what do you call it? Dimensional analysis. God, it's been a long weekend. Luckily, next weekend you get an even longer weekend, 3 full days, not 2.5 or 2 and
Martin Luther King Day?
0.7. Yes, we all shall celebrate Martin Luther King. And we will judge each other by our character and your character tomorrow, and not the pigmentation of our skin. So, and then you guys will have a test next Tuesday on Unit 6, which is a pretty big unit. What? Did you say owl?
I said
I said owl. It is going to be a little painful. So anyway, geothermal. Oh, and yeah, if you're at home, I'm sure 2 of you are watching this. I was planning on doing the solar oven test today, but that's going to get pushed back to probably Wednesday. It's supposed to be sunny that day, even though it may be a little chilly. And we're going to test our solar ovens in class. You people in class are going to be posting your predictions for what you think will happen. And then for for February the 26th, which is a month and a half away, you guys will, by that time, you will build your own solar oven, and you will design your own experiment, and you will complete that and turn it in by February the 26th. And that will be a 100-point grade, and it should be pretty easy. Solar ovens are not that difficult and don't have to be that complicated. And we'll see how that works. I did that in class last year and just took way too much time. So I think probably y'all can do it at home, and it'll save me some pain and heartache. All right, geothermal. What does thermal mean? Heat. Geo means?
Earth.
The earth. So this is heat from within the earth. Now, there's really 2 different kinds of geothermal that we're going to talk about. One, it is using heat that's within like the dirt and the soil underneath your home. And then another would be getting energy from, like if you live near a geologic hotspot where there were like geysers nearby or hot springs, something where there's a lot of heat that's up close to the surface that you could tap into. And so really those are 2 different types of geothermal usages. I think tomorrow I have a short video to kind of show you how a geothermal would set up would look in a home. I actually don't think geothermal is a bad idea in terms of renewable energy that can be cost effective for many people. And so it's something I think that's valuable. Tomorrow, the hydrogen fuel cell section. Now, keep in mind, the College Board presents all of these sections, and most of what you see here in the notes, I just expound and talk about them a little bit and discuss them with you. I think hydrogen fuel cells a load of horse manure, and I don't think it'll ever take off. So, but yet they still include it. If nothing else, it was did a fantastic job at killing the electric car back in the mid to late 90s. So if nothing else, we'll discuss it in that context. But anyway, geothermal energy is obtained by using heat stored where? Underground, which is brought back to the surface. Now, if you're talking about a geothermal power plant, heat would be brought back to the surface as steam. So basically what you would do is you would have to dig some deep channels or deep wells underground and put a pipe, and then you pump water down, and as it got hot and came back up, it would be hot and steamy, and you could use that steam to turn turbines, and y'all know the rest. Turn the electric generator and generate electricity. Iceland, if you'll notice here on 362, Iceland currently produces, now this is 10 years ago, this book's kind of old, about 20% of their electricity using geothermal. That's one of the few countries that gets lots of their electricity through geothermal. I would suspect it's probably even more than that right now because they have a lot of geothermal activity in Iceland. I don't know if you're familiar with that country. Lots of volcanoes and hot springs and things of that nature. It's also a good place to go have a good chance of blowing up. So hopefully that doesn't happen to our friends in Iceland that are tuning in right now on the YouTube. So, none of you. Number 44. Steam is used to drive a turbine, which turns a what? Electric generator, which generates electricity. So that is where you have geologic hotspots. We don't have any geologic hotspots around here. I mean, like you can go to Arkansas. There's Arkansas Hot Springs National. It's a national park actually. It's over in western Arkansas. But I'm not aware of any other geologic activity that's remotely close by to us. Now, that doesn't mean that we can't use geothermal to heat and cool our homes. So, the cost of accessing geothermal energy can be prohibitively expensive as it is not readily available, and you got to do lots of digging. So if you're doing the home type, you've got to do lots of digging. There's a lot of cost up front. And in most places, it's just you would have to dig so far down to get to any geologic activity, it would not be worth it. Okay? Some cases, it would be like thousands of feet into the earth before you got any geologic activity. You might go out to Yellowstone, though, and you'd be right there on top. You have steam coming up out everywhere. What if they took Old Faithful? Are y'all familiar with Old Faithful? The geysers? Anybody been out to Yellowstone? Y'all need to get out more. So we went out to Yellowstone a couple years ago, my kids and wife, and we watched, there's Old Faithful. There's actually a bigger one that was behind it that was going off too. Maybe they'll hook up a turbine one day and hook it up to the top of Old Faithful and use that to power the park. I doubt it though, because it only goes off every 90 minutes and there's not that much water comes out of there. But there is geologic activity close to the surface. So, and if y'all aren't familiar, Yellowstone is considered to be a supervolcano. It's a very large volcanic caldera. It's like tens of miles around. And if it ever blows up, we're probably like a third of the people on Earth are going to die, is the estimate. So, yeah, it's scary. And it's about due for a explosion. So, in the next 30,000 years or so, but we'll probably won't be around. So you'll be okay. Hopefully. They say it erupts about every 650,000 years, and they said the last time, and that's like, I'm sure it varies quite a bit. That's on average. And the last time, I think it was about 630 or 40,000 years ago. So, any day now, who knows? Where'd we go? So, what about the other type of geothermal energy? So let's say Sarah, that you move over to the '06 with all the rich people, and you want to introduce them to a new fancy energy source where they don't even have to hardly use any electricity for their $1 million homes. So let's go through and see what this looks like. 362, number 1, Isabella.
At the compressor, the circulating fluid is compressed to form hot gas. Heat is given off into the house from the heat exchanger as the gas cools to form a liquid.
All right, so a couple things you need to know here. If you dig down about 10 or 15 feet down in the earth, what's the temperature? What?
Warm.
You want the actual temperature?
Yeah, the actual temperature. Like, let's say you go in a cave, which is underground around here. What's the temperature?
50 to 60 degrees.
Probably about, where'd you get that from?
Up there. Ground heat.
Underground. I think it depends on which part of the earth. Around here, it's about 60 to 65, most places. So, at least fairly close to the surface. It's not going to get warmer you digging down 10 or 15 feet or 100 feet. If that was the case, people that dug wells around here would have steam popping up out of everywhere. So, yeah, if you dig and put something underground, usually the temperature is about 60, 65. So the first step, so in the wintertime, if it's 30 out, then you can use that heat stored within the earth, run water down there, let it heat up to 60 or 65, run it back in the house. They talk about using a compressor here, compress that heat, and then pump that into your house to help heat your home. Or you could use some auxiliary, like a little bit of heat on top of that to help heat up your home. But you wouldn't have to use as much as you would heating up from 30 degrees to 65 or 70, whatever you keep it in your home. Now, in the summertime, let's say you run some pipes underground and water goes down and it cools down to 60 or 65. You can then use that to what? Cool your home. So geothermal is a way of heating and cooling just from using the energy within the earth. Okay. Number 2, Andrea.
As the fluid expands and cools, it becomes a gas that is much cooler than the ground through which it will move.
Number 3, Antonise.
The warmer ground heats the cool fluid, which cycles through very tubing. Thus heating from the ground is essentially pumped into the building.
Okay, taking some heat out the ground, pump it in the building. Boom. So, what's the drawback with geothermal?
Expensive.
Yeah, it's expensive. You got to have lots of pipes and stuff, and you got to have lots of digging that takes place in order to put this into action. And so, the upfront costs are pretty expensive. I would say on the back end, in your book, it says on the right, so the left side of 363 at the top there, the operation of the pump requires some energy, but because you got to pump the water and stuff around. But in most cases, uses 30 to 70% less energy to heat and cool a building than a standard furnace or air conditioner. So over the course of the life of that heat pump, probably 20 years or so, you would expect to get that money back and probably even save money. It's just a matter of those upfront costs. And really, after 20 years, let's say your heat pump goes out, well, the pipes and stuff that are running underground are probably still going to be intact and still be good. So you might just have to replace the unit, but everything underground, the really expensive stuff, is probably going to be okay. Now, you'll notice at the top left of 362, Iceland. We said 20% of their electricity, but 87% of their homes are heated using geothermal energy. So just goes to show you can use that geothermal energy within the earth to help heat, and also, like I said, is any good Alabamian to help cool your home so you don't pass out and die in the summertime. All right. 46. In addition to, turn over to page 368. In addition, it can cause the release of blank. Excuse me. If you look on 368, one of the main disadvantages of geothermal energy, so actually getting steam from within the earth, is what? Releasing of?
Hazardous gases.
Hazardous gases. So digging down, some of that can release, process can release some hazardous gases. into the atmosphere and be harmful. And definitely it is geographically limited to certain locations. So those are a couple of the drawbacks. Okay? And that's really about all you need to know. Okay? Any questions there? All right. So, today, you guys online have a worksheet. You're supposed to do the first 3 of each 3 of these sections. Get to work.